Hello, I'm Kit, and this is my first talk. According to the Oxford English Dictionary, is a verb, apparently. Means to speak in order to give information or express ideas or feelings, to converse or communicate by spoken words, and I hope that today, if nothing else, I do speak in order to give information or express ideas or feelings, or at least converse or communicate by spoken words. So, what are my qualifications? First of all, this is my first talk, I already said that, so that's one qualification. Again, I'm sleepy, so that's another one of the multiple facets of qualification. So there's a couple quick qualifications. Originally this was supposed to be a 25-minute talk, but I have, using the power of sleep deprivation, expanded it to be a full hour. It sort of felt like one of those RPG simulators where you have a certain number of experience points to ascribe to different things, and I had to choose between coherency and preparedness and sanity, and I sort of did like a middle of each, so hopefully I'm coherent and sane. And this is enjoyable. Point two, I like ZIO very much, as Adam said. I used to do Haskell. Well, I used to do Ruby on Rails, very dynamic. That's how I started, and it was very lovely. And then I quickly, through a series of accidents, got into Haskell, mostly out of anger. I wanted to, attack and learn what monad and functor was and all these crazy words. And that's sort of a brain defect that I think a lot of functional programmers have. But I also appreciated, from the Ruby world, being able to do things quickly and enjoy the experience of that. And so when I first came to Scala, it was because I was looking for a Haskell job, and by sort of a rounding error, I got a Scala job, because there are no Haskell jobs if you don't have a PhD, or even back then, there weren't. And then I hated it for a good year, very much. I was like, I just want to be doing Haskell. This is worse in every way. I have to ascribe type parameters to things. There's no type inference anymore. I'm using particular functional libraries in Scala. And eventually I found ZIO, and it was sort of the perfect fusion for me, and I'd eventually got to the point where I didn't want to write Haskell anymore. I would not write Haskell again. I like a particular experience of writing code with ZIO. I think it's sort of, especially using the environment and some of the features I'm going to talk about today, it gives a particular experience that lets you think about your business logic, to be very cold about it, your business logic at a very high level, poetically, and then sort of delegate the details until you need to worry about them. And then when you're worrying about the details, you get all the benefits of functional programming, local reasoning, etc., and you can forget about the rest of the world and just sort of build a little bubble where you worry about the business logic, load all that into your head. But then there's not this sort of other awkward level where you then have to wire everything together. In many of the early Scala applications I worked on, there was like a 5,000, 10,000 line, depending on the age of the application, sort of initialization file that, when using futures was quite horrible and had a lot of vars in it. You would sort of lazily kick off database connections, acquire pools, and everything. It was just this huge spaghetti mess where the application was sort of wired together. And I think with ZLayer and using the environment in ZIO, there is a much sort of nicer experience that kind of just dissolves, if you will, that entire class of problems. And it's very nice. And I hope to communicate that experience to you today. So we're going to do some live coding. I like ZLayer. We're going to talk about, briefly at the beginning, what ZLayer is, what the environment is, a few ways of thinking about it. I know it's been confusing in the past. I think in ZIO 2, which we're going to be using today, we've improved a lot of things. And I hope to share some of the joy that I experience and the anxiety eradication, deracination that I experience when using ZLayers. Okay. And we're going to kind of build a little later on this little meetup application as far as I can get in however much time I leave for myself. And we're going to take a look at how that works. But first, let's talk about ZIO and get a little bit of an intuition for working with the environment. Well, as we know, a ZIO, according to the Oxford English Dictionary again, is a computation in a context that either fails or succeeds. So we have this success type for a computation. And we have a failure, the E, the error. And then we have this mysterious R, which is the context in this sentence, right? It's the context, or maybe the requirements, you could think of it as. And sometimes it's referred to as the environment. An R by any other name is just as useful in this case. And we're going to start by exploring the environment, because that's probably the trickier thing. We get errors, we get results. Environments, maybe this is a little tricky. Well, it allows us to model function parameters at the level of values. That's kind of one way of thinking about it. All of your intuitions about function parameters, the many great things you think about function parameters on a day-to-day basis, you can apply to the context type parameter. And what are, that does not beg, but raises the question, what are your intuitions about function parameters? They're so boring that you probably don't think about them too often, but let's go over them very quickly. So if you have a function like this here, clear database function, which takes in a couple of services, it's sort of requiring its parameters here, right? Inside of this function, we can refer to the parameters. We can call methods on these traits. We can call log on the logger. We can drop all the tables of our database. And so internally, we can reference the parameters of the function. That's one of the intuitions. And then externally, dually, as a functional programmer might say, we have to do something different, right? We can't just do this. This will not compile. It will yell at us. We need to, in order to sort of fulfill the promise of the function, in order to get back its result, in order to execute it, we need to give it what it needs, its requirements, its context, its environment, its parameters, right? We need to feed it some logger and some database before we can get anything done. And those are our intuitions about function parameters. And they're very boring and simple. And we can use that good, boring, simple knowledge to understand the environment. So here is sort of the ZIO equivalent of the same function. It's just a val, though, because we lift these service dependencies into the context parameter, into that environment parameter. And in ZIO 2, we used an intersection type, sort of as a phantom type, which I think was that scary type thing. It's very simple. It's just a type that we're using that's never actually evaluated. We're just using it to track what's in the environment. So we're saying, really, you can read this as an English sentence. This needs a logger and a database, just as you can read this in your head as, whatever programming does to your brain to break it, and you read this as, I need logger and database in order to execute this function. You need a logger and database in order to finally make this ZIO effect runnable. So internally, we can refer to logger. We can refer to the database. We can access these. These would be accessor methods. We'll get to these in a moment. But we can refer to them. But we have sort of now this dependency that we need instances of these. We're sort of referring to some abstract logger, some abstract database in the environment. We're delegating to something that we don't have yet, in the same way that in here, we're delegating to some logger and database that we don't have yet. So internally, we can access our environment. And then externally, well, this actually compiles, unlike the version where you don't apply function arguments, but it's just going to have the same type, because these are values. Sort of one of the benefits here, you don't need to sort of thread parameters around. This will compile or convert it, expand it into a function or something. But in order to do the same thing of applying these arguments, if you will, of removing the dependencies, we call provide, and we feed it layers that correspond to our requirements. So instead of just passing in the values directly, we use this additional abstraction known as layers. But really, that's kind of the environment in a nutshell. We track what we need, same as how function parameters track what we need, and then we can provide them. Instead of calling it, we literally call provide and give it a list of everything that it needs. And it's a little trickier than this, because these layers can have their own transitive dependencies, and that's kind of where a lot of the joy and beauty of this comes in, but we're going to get to that momentarily. Now, briefly, an aside on these little accessor things, because we're calling logger.log. We're calling some method on the companion object. What is this doing? Well, let's break this down very quickly. There's this method called service on the ZIO companion object, which technically it's not the fundamental environmental operation, yet it is, we could think of it as that, despite its implementation details. And what this does is it basically says, if you give me an integer, in this case, an int service, we will give you back an int. So if you have an int in the environment, we're just going to reach into that environment and give you back the int. It's kind of like the identity function, almost. So the function equivalent would be this. The method equivalent would just be, OK, if you give me an int, I will pass that int back to you. And then so if you call that function, you're going to get that int back. In the ZIO world, if you provide a layer that contains an integer, you will remove that dependency, and now you can execute it. So we can call it with a runtime, and that will get us back our 42. So these are sort of equivalent. But that's not really how you do it in the real world. I mean, you could put an integer in the environment, but generally we use this for services. It would probably, if you did really want an integer, it probably had some meaning in your application. You'd probably want to wrap it in a case class. But to make this a little more canonical, let's make a logger trait. So generally, what's in the environment are traits. So here we have a logger trait that can log a message and return a ZIO that does some side effect. So we're going to change the functional version to basically be identical, except we're just using a logger now. So this is just going to return some instance of a logger. We don't know what it's going to do. Maybe it's going to print to the console. Doesn't really matter for this example. And so to change our ZIO example, this probably would look a little more canonical. We're going to grab a logger out of the environment and return it. But chances are you probably want to do something with this logger. You might want to call the log method. So what you could do is you can call flatmap on this effect, which gets you back a logger, right? And then call that log method on that logger, getting back the unit, logging it in this case. So now, calling unsafe run on this effect is going to log hello, because we're getting a logger out of the environment, then calling that logger's log method. And instead of doing flatmap, there is a convenience method called service with ZIO for the ZIO effect variant, which basically just combines it into one thing. So instead of getting and then flat mapping over it, we're going to get and then call this method on it. It may as well be implemented like this under the hood. And it can infer its environment. So it makes it slightly nicer to work with. Cool. And so to go back to this, what we saw before, logger.log would basically just be a method on the companion object here that looks like the same interface, except its implementation is basically just delegating to some logger in the environment instead. So it lets you sort of write your programs. This is very useful for in-test code, where you can write your code in this very sort of high-level way, or in maybe example code, as we're going to do in just a few moments. And in Scala 2, because it's a little boilerplatey, there's this accessible macro, which will just basically implement all those accessors, as we call them, on the companion object for every method in your trait. And unfortunately, there are no annotation macros in Scala 3, so we did something, the best we could do for now, until there are annotation macros, which is we have this accessible trait where you can extend upon the companion object accessible, parameterize it by the trait, and then notice what happens down here. It adds an apply method, where you just sort of do the same thing. So it changes from that nice dot notation to now you have to give a function from that service to the result, and it will flatten it nicely for you and basically do the same thing. It's basically implementing this method. You call apply, you give it a function from logger to some ZIO effect, and it will call ZIO service with that method. So there's some information there. Okay, so ZLayers. We should probably briefly touch on these as well. These are the value level equivalent of constructors, sort of. They're sort of a superset of ZIO. They're a superset of Z-managed even. So they involve the environment. They can require another environment. This is the same sort of semantics as the ZIO environment. So we use that intersection type or that and type in Scala 3 to track our requirements. But it also actually outputs one of these environments as well. So it's another phantom type parameter now in ZIO 2, where we're just tracking everything that these can output. So these can construct one or more services in your environment. So you can produce one or more services, they can fail with an error, and they can also require other transitive service dependencies. But basically, they can be built from ZIOs. All of your intuitions for ZIO effects and whatnot can translate to these. So let's talk about how to define them. In ZIO 1, there were probably too many ways of defining them, and we wanted to simplify this space. We couldn't fully dissolve this, because you might need sometimes to create ZLayers in interesting ways, but we can at least simplify it and make some recommendations. So today I'm going to talk about mostly best practices, as far as that's a thing, just from experiences of teaching people and using it in large code bases with lots of programmers. So basically, the simplest way of constructing a ZLayer would be to, I'm getting hot in this stupid scarf, would be to, sorry, Vigo, would be to call ZLayer.succeed. So just as you can lift a value into ZIO, you can lift a value into the ZLayer. So here we're just making a ZLayer that cannot fail, that has no transitive dependencies, and that will return here this config type that you put in it. So that's one way of making ZLayers. And there are type aliases, which, just for the sake of horizontal compaction, I'm going to rely on. So a ULayer has any, it's basically the same as this, right? So any as its environment and nothing. So whenever you see a U, it has no environmental dependencies, it has no errors. Perfect. ZLayer, nice and short. The other way I'd recommend creating ZLayers, generally this can get you most of the way there, is to call the toLayer method on a ZIO. So if we call ZIO.succeed, we'll get sort of the same thing in ZIO world. We'll get a ZIO effect that just returns this config, and then we can dot chain onto it toLayer, basically just translating, lifting everything into a ZLayer quite straightforwardly, which in this case we may as well have used ZLayer.succeed, but this allows us to do some other interesting things using what we already learned about. We'll take a look in a moment. So if we have some effect that has some environmental dependencies, we can just call toLayer on it, and it will get us back a ZLayer of those same things. So if we had some effect that gets us the users, given a database and a logger, some user service, we can get a ZLayer that does the same thing for us. And we can do the same thing with zmanaged. So there's a toLayer method on zmanaged as well. So ZLayer doesn't really need to be its own thing. It's kind of, we'll see why it exists, but you don't really need to store too much information in your head about it these days. And some canonical example would be the following. So we might have a user's live, an implementation of our user service that has its dependencies here on database and logger, and has some method, and we'll assume that inside of these question marks it's going to use the database and the logger in some way and return a user at the end. And we could have this layer definition that's going to just, using that ZIO.service method that we just looked at, grab a database out of the environment, grab a logger out of the environment, and then construct an instance of our user's live implementation here, and then convert it to a layer, because that's ZIO's. This would lift it up into the world of layers, so we can use it to provide things. And also, if you wanted to, you can do the same thing with managed. So we can add a close method to our user's live class here, in case it needed to shut down a database, release some resources that it allocated, and then we can first call toManagedWith on our ZIO effect, giving it a method that would close the ZIO effect, and then call toLayer on the new managed we get back. So this will acquire this users at the beginning of your application, run your whole application, and then when that portion of the application you provided it to closes, it will call the close method here, or do whatever you specified, which is sort of nice. Okay, but that's a little verbose, what we did here. And so we're going to take a look at this in a moment in more detail, but toLayer also exists on functions. So if you have a function from A, B to C, you can get a ZLayer from A and B that doesn't fail to C. So it just basically lifts a function into the world of ZLayers. So we can call toLayer on this function, which is a little weird here, but the reason we made it was to sort of fulfill what is a pattern that will show up 90% of the time when you're doing this, which is going to be this case, where you have an implementation that we recommend be a case class that would extend some trait. And instead of doing this, what you can instead do is just get the apply method of your case class, which would be a function from its parameters to its result type. And then you can call toLayer on that. Yay, and now it's made a layer equivalent of this function. So we've lifted a constructor, literally, as I said before, into a value. So it's a value version of a constructor. And it can be composed in interesting ways. So let's take a look at some of those ways. First of all, if you have one layer and you have another layer, you can combine them horizontally. Now, we're not going to be using these operators too much anymore, but these are still concepts that you might want to understand. And then we can get back a new layer that's going to return both a logger and a database. So once again, this is a phantom type parameter. This is not returning a trait that extends both logger and database. This is going to be that environment out. So we're tracking the fact that inside of this layer, we have both a logger and a constructor, and we can use this. And then, if you have another layer that has some transitive dependency on a second one, so we're going to get a user's service given an analytics service, if that's one layer that exists, and we have an analytics service, we can provide that to the other using this triple arrow operator, and then we're going to get back a layer that has no dependencies and just provides the users. So the goal here of an application is to write your code at this very high level where you're delegating to implementations of traits, only at the level of the business logic that you care about at that time, at hopefully a high level. So we can implement some method here. Maybe we want to attend some event. So we have a user ID, we have an event ID, And then we're going to delegate to these accessors inside of this example. So we're going to get some user, we're going to get some event, and then we're going to create an RSVP for these using these very high-level methods. And this method perfectly describes the semantics of our code, this little block of code. But it's also completely agnostic to the implementation. It's coding to an interface, but it becomes really detached in a way from providing implementations of these services. And you can sort of build your implementations. You get sort of this Lego block building experience. And using some of the new features we added, it can be sort of very nice and guide you in this way. So here's just a function that's going to, give me a user, an events, and an RSVPs. If you have some implementation of these, I will call these methods in this order. This is the very high-level sort of semantics of my program. And what we need to do here is our goal would now be to construct a layer that perfectly fits the environmental requirements and provide it, right? We need to provide it its arguments. And this is what we need to do. So say we had a test version of our users service and a test version of each of these. So they had no transitive dependencies. They were just test versions. Maybe they had some in-memory ref where they tracked the users and the events and the RSVPs and whatnot. Then we could combine all of these together and provide that to our service. So we could have this make RSVP ZIO effect that needed these things, and then we can call provide and then pass in that zip together thing. But as I said, you don't need to really worry about those plus plus operators anymore. You can just do the following. You can call just provide and start there. And what you're going to get is the following error. It's going to tell you that you must provide the layers for the following 3 types, because it's a macro, and it's going to introspect and know what requirements are needed here. And it's totally inferable as well. Say, if there were an implementation, it would know this, and you can use IntelliJ or VS Code to add this type description, or you could just not, and it would still give you this nice error here, which can actually be nice and will be a tip that I will give in a moment, is to sometimes leave off type descriptions in key places. We will discuss why. Not necessary, but a bonus. So now I can provide a user's test implementation. So I'll have a layer on the companion object called test, and now, if I compile, it's going to remove that requirement. So now only events and RSVPs are needed. So we sort of get these set difference operators on intersection types in a way. We're just using this to track what we need, and the macro can do set difference operations on it to figure out what's remaining. So we can provide events test, come down to a single layer, and then once we provided all of them, behind the scenes, it's going to traverse this dependency graph, and sort of, right now it's quite simple, just basically going to write the code that you would have used to have to write manually, the plus, 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 plus between each of these. But it's going to do that for you, irrespective of order. So let's say we had a more complicated layer. Let's say we had one that had transitive dependencies. So a live implementation of a user's service would maybe need that database and maybe some configuration as well. And then maybe that database had an implementation that itself had requirements, like a database config and maybe a Hikari connection pool. Well, if we swap in users.live, we're going to get the following error. So it's going to say, required by users live, now you need database and user config. And we can now provide database live, and it's going to say, okay, well, you still need user config for users, but now you need these 2 other dependencies for database live. So it's traversing this graph and sort of collecting all of the errors, and applicatively, I will say, as a functional programming conference. Cool. So it'll give you all the errors, and it'll be very nice, hopefully. And so you can continue doing this until you've provided all of the layers, and then it will just compile, and it will have used that plus, plus, and arrow, arrow, arrow behind the scenes. This is sort of that lower level DSL that is a solution to this problem and a nice functional representation of this. But at this layer, just once again refer to Adam's wonderful talk from yesterday, we can dissolve that problem, and you can just worry about what you want, which is picking implementations, kind of like Lego pieces. You're just reaching into your back pocket and just say, oh, I want this implementation. It's going to say, well, then you need these other things. And you're going to, all right, let me reach around my big jar of layers, of Lego pieces, of constructors, and throw some in there, and sort of watch this get built. Of course, it could be nice to introspect what's happening. So you can do this ZLayer.debug.tree layer and throw this in there, and it will print the following to the console. So you can sort of see how it has constructed. Oh! Oh! Oh, it's such a silly feature, but it's quite nice, isn't it? Yes, these silly things are lovely. I'm happy with that one a lot. And there's also ZLayer.debug.mermaid, which is not a troll, but it will print out a mermaid live editor link, which will take you to this. and you could see a mermaid graph. So that's more applause! Visuals! Silly visuals! Thank you. So that's super fun. And we'll take a look at that in practice, hopefully, in a moment. But first, to sort of summarize some of these best practices and tips, the service pattern, which is kind of the recommended way of building these services. It's not really much of a pattern. It's quite simple, luckily. But just to put it in one spot, a couple of tips. The idiomatic way to organize your ZIO apps and your ZIO services. Well, one would be to define your service as a trait. The second would be to implement your service with a case class. And the third would be to create a layer on the companion object of the trait or potentially the implementation, depending. We could talk about that. So defining your service as a trait. So we have this events trait. We're going to call a get method on it. We'll just keep it simple. We get some ID, and we're going to try to find this in maybe our database, maybe in our in-memory ref, maybe just return none always, or whatever our implementation wants to do. Notice here that the environment is any. Task is a type alias for a ZIO that has no environmental requirements, and it can fail with a throwable. And we're just going to keep this simple and just use task here. So any, you basically always want to have any as your environmental constraint in the trait. And that's because we use layers to determine transitive dependencies. And this allows you to, if we had a dependency in here, say we needed a database here, we would not be able to implement an implementation of events that did not need a database. They would all need a database. We'd always need to come up with a database, even if it were an in-memory implementation. So layers are sort of how we build these constructors, and we represent these sort of nodes in our internal service dependency graph, if you will. So that would just be a best practice. There could be some cases. If you know what you're doing, break the rules if you know why. But that would be a pretty big recommendation. And this allows for the flexibility in implementations. So then, implement your service with the case class. So we're just going to make an events live that follows events. And then we want to extend it, add as parameters its dependencies. So internally, to implement get, for the live implementation, we might want to call out to this fake database implementation I made. This is not an existing library, I don't believe. Just made that up for simplicity here. And you add your transitive dependencies as parameters to your case class. So we might have a logger as well. And so we're going to log, and then we're going to get from the database, which, if these are also implemented with the service pattern, their methods will not have these transitive dependencies in them. And so you can sort of, by choosing which layer we're going to provide for these, we can pick their transitive dependencies. So it's another reason to keep your implementations flexible. If this database needed a connection pool, well, then we would need to provide one in here directly. But maybe we want an in-memory database implementation or something like this. OK. And then we can have multiple implementations as well. So here's one that would need a ref. So it can be an in-memory version that just grabs it out of this mutable reference. And then lastly, to create a layer on the companion object, well, this is where we can use that apply method. So this is kind of why we recommend using it as a case class. It's really for two reasons. One is, if you do a case class, it's going to make mutability a little ugly. So you're probably not going to ever want to see a var inside of a case class. So just use that sort of sensibility that you might get for free to keep things nice and functional. But also, just conveniently, it gives you an apply method. And you can use that to get a function, and then you can use the toLayer method on this to convert it into a layer, which will get us just back a layer that represents how to do this. So it minimizes as much as possible for now in Scala 3 and Scala 2 the boilerplate that is required. And I would actually recommend potentially for these implementations not adding type annotations. Because then, as we'll see hopefully in the live coding segment, you can change your implementation just by adding new parameters. If we needed an analytics service in here, we can add an analytics service, call it, and then this will automatically infer the new type that it needs in analytics. And then wherever we have provided the events.live, this will now know that it transitively requires an analytics. And we'll just get that nice error at the top of our application. And maybe in our tests, wherever we're using this, that particular live events layer, that, hey, now you need to pick an analytics implementation. And you can say, OK, I want to use a test analytics, I want to use a live one. So it prevents you from having to regenerate the type of this. So that can be a nice thing for these layer definitions, to leave these as inferred. But that could be annoying as well if you like seeing those in GitHub or something. OK. And this, once again, is just syntactic sugar, essentially, or an extension method on function that just does the following, as we looked at. So yeah, that's the service pattern. And now we're going to code as quickly as possible. So here we are in VS Code, because I'm using Scala 3, and it's growing on me a little bit, VS Code these days. And we're going to quickly build sort of that meetup application that we looked at. So quickly, I have this ZIO.howdy extension method that we're going to use, because it makes everything nice and visible. Otherwise, it would sort of get lost in there. I don't have time to highlight everything all the time. So yeah, we're going to make a program. And what we're going to do is something like the following for now. We're going to, we want to be able to call events.all, get back a list of events, and then maybe we'll just call that ZIO.howdy method and just take a look at what those events were. Obviously, there is no events, and there is no all, there's nothing. So we're going to do this. So let's start implementing things. Okay, events, users, RSVPs, meetup, let's see what we can do. So first thing, we'll need actually an event type to use in this case. So we're going to need an ID, which is an integer, and then, oh, thank you, sort of thank you. We're going to have a date, which is going to be a local date. And let's see, cool. So that will be our event type. And then we're going to have a trait called events. I'll just pluralize this for the trait, which I found to be nice. We don't have to postfix everything with service all the time. So this is going to be our events service. And we are going to have a few methods. So we're going to get an event, give it an ID. So this can return us a, let's say, just go with task. So maybe it can throw, and we're going to get back an event. And maybe it will just blow up for now if it doesn't exist. We can also return an option, sort of up to us. I'll return an option. Okay, and then we're going to have an all method. So this is going to basically get us a task of a list of events, thank you. And also we're going to be able to create an event, also thank you, to Copilot. Copilot's going to hopefully help out a lot and not make me sad. So that's the first step. The second step would be to make an implementation of this trait. So let's do events live, and this will extend events. So what we're actually going to do here is we're going to have a JSON path, so a path to a JSON file, which it somehow miraculously understood. I don't know how that happened, but that is indeed the path. And then we're going to do some stuff. So ZIO from file. This is not quite right, but I'm going to steal this. So I'm going to steal at least for that bit there. So we want to get back an option of an event, right? That was our interface here. So I actually added a helper method here onto ZIO called from file or read file string, which given the path here is going to get us back the contents of that file, content, and then we can call from JSON, from ZIO.json to parse this out into, it's going to get us back an either. So I can call ZIO.from, and it will take the string error message and lift this into a ZIO that can fail with that string and return a list of events if it succeeds. But then we're going to map that error. So we'll say or else fail, and we're just going to make a new runtime exception for now, called could not parse events. And is this happy? I'm not sure. It seems to be slightly sad, so let me quickly open up my terminal. Oh yeah, duh, because I need to implement a codec for this, which should only take a moment, if you go away there. So I need a companion object for my events, and I will just say given a codec, a JSON codec for an event, and I'll say derive JSON codec.gen, and it will build that for me. So now it's going to be happy. That's our implementation of get, which will make all quite simple. All will actually rather the other way around. All, this is sort of the implementation of all. We'll do this. Perfect, and I'll delete find here. So we'll just get back all the events, and get itself will be basically very simple because we'll just delegate to all. And let's see, can Copilot help? Yes, it can. And for create, it's going to be a little weirder because we have name and string. Let's see. We're going to want to get an ID for our event, right? So we kind of want this to be nice and functional, and so we can test it in a nice deterministic way. So let's ask for the random service to start with. And I could say random.nextInt. So this is going to get us a random integer for now. And then I can make my event equal to, well, using that ID, and then taking the name and the date that the user has provided. And I want to write this to the JSON file. So I can get all of my events. I'll need all of my events. And then I can make my new events by appending my event to the end of my events list. And then I can save it back. So I can say ZIO.writeFileString, another helper, and do the following, to JSON pretty, and return finally my event that I created. OK, so that's a lot. And the last thing we need is a layer on our companion object, if it doesn't freeze. Come on, computer. Live coding, perfect. No, don't freeze. Vim, all right. One sec. Going to quit stuff. My computer has stopped responding, which is very sad. No, you bastard. Apologies. I'm going to force quit, I think, if that's even possible. Everything's so tiny. Yeah, the option key seems to have forgotten how to respond. I'm going to unplug and just replug this thing in case that screwed up. Sorry, visualization booth. This should make things more exciting, but we have 19 minutes before the fire alarm sounds. We should be fine. This will be great. Option key, you're going to work now. Yes, we're back. Option key. Okay, so let's go super fast. So next, we're going to have our companion object. We're going to want a layer, so we're going to make a live implementation, which is basically going to be eventsLive.apply.toLayer, right? And this is going to get us back a layer that needs its dependencies. So it needs a random, and it's going to get us back an eventsLive. And then we want these accessors, and just to make things fast, I will use this accessible macro, not macro, but trait. So we're going to extend it like this, and so now I should be able to go back to my main file, and instead of calling it like this, because I want to make sure we have enough time, I will call all, which should do basically the same thing. And now let's see what happens if I try to compile this. So it's going to, everything blew up, so start again and call run. And hopefully it will give us back a very nice error message that says, yes, the following. Hey, your program, if I can scroll, which I cannot, it's going to list, and I'll give it half a moment to live coding. To respond, is it completely sad? No. Can we zoom in on, if I flip my computer around, can we zoom in on the camera? Oh, that's a shame. Sorry, I'm going to unplug again. And try one more time. That's exciting. But we still got 18 minutes. We got this, I think. VS Code. Why? Maybe I should switch to IntelliJ. Yeah, I'm going to switch to IntelliJ. It's our only chance. Install update. No. It's not the time to install update. Or to respond to, okay, now let me try a different hole. No. IntelliJ, maybe I should try everything simultaneously. 17 minutes, there's still time. Okay, let's see. Oh, very small, right? Readable. This is the wrong project. Let's go to terminate this. Let's go to commands. Okay, my keyboard's not working, so that's wonderful. Oh dear, that's such a shame. That's a bummer. No, computer, you bastard. It was working so lovely. Let me see if it works without being connected, and then I can flip around, and we could zoom in real close on me. I'm just kidding, but let me see if it works without. Yeah, it works when I'm not plugged in, so I'll just code it real quick and describe can we see? Zoom in, if everyone gathers. Okay, I'm going to try to go direct to HDMI instead of using this USB-C thing. This is, okay, getting increasingly exciting. Okay, it seems to be, oh, well, now it's huge again. Okay, great. Now it's tiny. And this is the problem with this HDMI thing, is that it makes my computer font change every 10 seconds. Let's see if it stays consistent, because I can type, which is better than not. And now it's getting huge, and so that's fun. And now it's getting small again, and it seems like it's reconnecting. It is connecting. So we seem to be cursed by some sort of phantom type parameter or something. I'm going to try again, because there's nothing else I can do, but try repeatedly. Let's try to run this. Come on, you can do it, technology. Okay, good. All right, so I can scroll. So we need these things. I'll edit this later. This will not be known to the outside world. Thank you, Zoom people, for tolerating this. It died again. Well, I don't know what to do. I could share my screen directly to Zoom. Could that potentially work? Oh! How good is your camera? Can we zoom in more? All right, so it's a little blurry. How big can I make it? Yeah, it's all right. Oh my God. All right, you sons of bitches, let's do this. Okay, let's see what happens. Thank you so much. Okay, I can kind of stand like this. Any dandruff? All right, let's do this. All right, so we have events all, and it says now we need these three giant things. These huge things, we require them. So we can start by calling .provide, and it even gives us some nice documentation assistance, as James Ward talked about yesterday. So we can learn all about what layers need to do and how this provide thing works. But if I add just provide with nothing, it'll be a little more specific that says, hey, provide some implementations for this. So we're going to start with events.live, which will satisfy that dependency. And now you need for events.live random, and you need random in console for, well, ZIO.howdy is very complicated, and it outputs a random number of the word howdy. So it needs that, of course. So now we're going to see a list of events. Yay! That was dramatic. Functional Scala 2021. Thank you. ZIO World, as well as Alex Ioffi's house party, which will happen next year. Cool. So that's the beginning of this experience. And now we're going to need a couple more things. So we have 13 minutes, and we have the power of, I already made that JSON file, obviously, but now we have the power of Copilot. So let's see if it can help us out at all. So we're going to eventually want the following. We're going to want a case class for user. And yeah, we'll just steal this. Maybe we'll make it an email. We're going to have our object for user, which we hopefully, yeah, has a codec. Thank you, Jesus. And we have a trait, which, thank you, Copilot, is going to basically look identical. And then we're going to have, of course, a case class for users live, which will also need a random and extend users and have a JSON path and et cetera, et cetera. We're going to have all users. And we're actually just going to simplify it and just get, no, we're going to want the get method, actually. So let's do this. Come on, get, yeah, get, implement that. And we're going to forget about creating users for now, just for the instance of time. We're going to get them. I had a few dummy ones. Great. And lastly, we're going to need ourselves an RSVP, which is going to basically be a user ID and an event ID. And we're also going to want a codec for this, so we're going to make RSVP. And we're going to say given JSON codec of RSVP. And then we're going to have a trait called RSVPs and basically do the same thing. Do another service here. We're going to have the get an RSVP and create, et cetera. And then we're going to have case class RSVPs live, and we're going to have a random service, and it's going to extend all this nonsense once again. Thank you. Please just keep doing it. You can do it. You're the best in the world. Oh my God, it's so smart. Look at what it did. I love Copilot. We're in AI God's hands now. And then we do want create, so I'm going to make a for comprehension, and we're going to do basically the same thing we did before. We're going to get an ID, so I'm going to say random.nextInt. This is going to be the ID. And oh no, we don't need an ID at all. We're just going to create one. So we're going to have to get the old RSVPs. So we're not going to, yeah, we don't care about the random integer at all. We're going to get the old ones, and then we're going to write it to a string. Wow. But of course, because of for comprehensions, thank you. Don't have time for your bullshit Scala right now. We need to do that, because it does not understand an equals in the front. Odersky, please. If you start with an equals, just figure it out. You can figure it out based on context. We don't have time. OK, great. And now we have these three things, which means now we've done this, we can make our very high-level meetup trait. Oh, we need one more thing before I forget. We need the implementations of these, right? We need our live implementation. So we're going to say live, and it's going to be quite simple. We're going to be doing this, right? Just turning the constructor definition into a layer definition. So object users, and we'll do this. There we go. Hey, it's super smart. Users live, and there was no RSVPs live because I did not create that. Or did I put it in the wrong place? Yeah, I put it in the wrong place. RSVP live, so this should be on RSVPs. So the one downside with the pluralization approach is that. So val live equals, come on, there we go. And now you're going to compile, aren't you, you little computer, you. All right, so trait meetup. Now we've made it. And now we can create our high-level sort of code here. And we're going to just make a method called RSVP, which is going to take a user ID and an event ID and get us back an RSVP. And this is kind of going to be, this could be used in maybe a ZIO HTTP service. This can be used anywhere. In an HTTP service, maybe a CLI. This is going to basically a high-level, semantic-level description of what we want to do. And we can now delegate to these lower levels. So we're going to make once again, if any of my snippets work, a meetup live implementation, which will extend meetup. And I'm going to keep everything open. Sorry. We're going crazy. So, and now, let's see what we want to do. We need to return a task of RSVP. Well, we could just delegate to our RSVPs service, right? So in here, I'm just going to add it as a parameter. And this is basically the same implementation. So I'm going to say RSVPs.create and pass in those things. There. and delegate that. And it's basically the same at this point. So let's go onto our object meetup and make a live implementation and this, and we're going to extend our accessible meetups method. Great. And then over here, oh, by the way, I have this empty RSVPs JSON file, so we can see if things work in a second. So now I can go to meetup.create, so what is it, RSVP, and we'll add the third user to the third event. And we're going to get some issues, which says, oh yeah, you need a layer for meetups, you haven't given me one. So let's do this. Let's do meetup.live. And now it's going to say, okay, now you need RSVPs, because it needed it in this layer definition. It's traversing this little graph. RSVPs.live, let's do that then, which needed a random, but that's okay. It all worked. And if we go to our JSON file, which was just empty, we now see two versions, because it's not a real database. So there, every time I save, it's going to add another one. But we've created an RSVP, and every time I save, it's creating a new RSVP. So that's super fun. But great. Now we can sort of get a glimpse at the user experience of this. We've built our application, so now we can just add to this. It's very simple. Right now, we're just delegating to RSVPs. But what if you wanted to return a full RSVP? Right? If this were to be a JSON API, you'd want to have all the information. Like, you'd want to have the full user in here. You'd want to have the full event. It's not just a matter of, we don't want this sort of like database optimized version, we want the full RSVP. So it's not going to quite work as it stands now. We do want to call RSVPs great, we still want to save it in our database, but we also want to do a couple things. We want to make sure that the user exists in the first place. So we want to be able to call users.get, right? But instead of doing it with this accessor, we're going to always depend on that service here. So this allows us to just grab some service in the environment. And I can call user ID here, and then event, I can say events.get event ID. Events. And then we can return a full event, full RSVP, user.get event.get. Of course, I'm not going to do these .gets. I'm going to say .sum or fail, and then I'm going to make a new runtime exception, user not found. And then I'm going to have Copilot do the same thing for event not found. And then it's going to be sad that I'm overriding method type. Oh yeah, so I've given it the wrong type here, because now I've added this full RSVP in the trait, so let's do this. And it's going to say, now you're missing stuff. So I just changed what I needed in my implementation, and all the way back at the top of my application, it's going to take me to where I need to now provide new layers. And it's going to say exactly what I need. Oh, you need particular implementations of users and of events, right? 7 minutes, baby. And it did it. And so here's our full RSVP, where our user is Bobo the Clown at gscities.gov, and our event is Alex Iaffi's house party. So we can sort of extend our functionality without worrying about wiring our application and building this huge thing. And so just to show some more of this, we're going to make one last thing called analytics, right? Because we're going crazy. We're going to have a track method. We're going to have a message. This is going to be a string, and it's going to get us back a task of unit. Object analytics, let's just go super nuts. We're going to have an analytics live, so Copilot is very helpful now at this point. Oh, my screen is so dirty. Oh my God, ew. Extends analytics. Sorry, internet, but okay, cool. And now, so in here we could just say let's say ZIO.debug, and just, or maybe we can have this rely on console again. So console is console, and we'll do console.println, and we'll throw in the message, whatever this was. So pretty basic. And now, once again, we can add this to anywhere we want. So let's first start by adding it to meetup.live. We can put it anywhere we want in this. So analytics. And now we can call out to it. So I can say analytics.track, and user is attending event name. And we get an error at the top of our application that we need to fill this in. So let's just do anywhere, analytics.live. And remember, this needed a transitive dependency, but we've already provided a console for some other reason. And so here we see, oh yeah, Bobo the Clown is attending Alex Iaffi's house party. Great. And we could also do the same thing on like our events service. And we could add analytics inside of events live. So analytics. It doesn't matter where in the stack that we do this. And here we can say, analytics.track, trick. And then we could say whatever, created, oh yeah, events.all. Okay, I guess I called events.all, which is actually going to get called in this implementation, so maybe that's even better to do. So that's going to say events.all, right, because we called it to get the event, because the implementation of a get event calls this, and it just works. We didn't need to do anything else. We just added the dependency, and we get to totally focus on, in this very strange, constrained, shrunken down view, our application, which is cool. And finally, to do the thing that makes you applause for some reason, let's take a look at the, the tree. So here we go. We needed console, random at the top level, and here we go, the ZLayer wiring graph. Our meetup
used analytics, it used users, events, and RSVPs, and then recursively it needed a console, users needed random, events needed analytics again, so analytics was used in multiple places, and so on and so forth, right? Meetup needed analytics, events needed analytics, and keep in mind that this is going to be a single analytics, because that's one of the powers of ZLayer that I didn't really mention, but it's not going to instantiate analytics multiple times. So if I go to my analytics object, and I can sort of tap my layer here and just do ZIO.debug acquiring, I'll just do doing this, we should only see ahoya once, and we do, right here. So it's going to instantiate this analytics, realize that where it needs to be shared in this dependency graph, and plug it in everywhere it needs to go. And as the last thing, because you actually didn't applause, maybe because I'm speaking too quickly and you sense the time, you're very good, because the alarm's about to go off, we're going to look at the following, which is this horrible link, Mermaid Live Editor link. Let's take a look at it. Come on, Mermaid. The final frontier. That's a big-ass thing. All right. So here's our tree. Meetup needed events. It needed users. It needed RSVPs. RSVPs, users, and events all needed the random service. Events needed the analytics service and console. And I think Meetup Live also needed an analytics live, so maybe that's an issue there. So you can boo if you'd like, and it's so blurry. But yeah, it was going to be exciting, and it was exciting. So thank you.